Hey everybody, welcome to a solving quadratics review video. I generated like 8 problems that I haven't seen yet, and so I'm just going to do them as if I was a student and I was told to solve these problems. I'm going to use all 3 of the strategies we know, which are factoring and completing the square. We'll do a few of, completing, where's my pen? Completing the square, and then we're also gonna do 1 or 2 of using the quadratic formula. So if you want to follow along, watch this video, practice for yourself, I highly recommend it. Obviously you could use the quadratic formula for any of these problems, but if we ask you to factor it, we do want you to factor it, and factoring is just the most efficient out of all of the ways, and the better you get at it, the less you have to think, which is a good thing. If you want to follow along, I would recommend getting some paper, just a piece of scratch paper to follow along and write the problems, as well as you are going to need some sort of calculator that can plug in the quadratic formula. You can actually emulate the TI-84s that we use in class using an app called Wabbit Emu, like that. It's in the company portal of your school laptop. It looks like this. So I can pull this up on my screen. Or you could maybe download it if you have your own computer, if you just Google Wabbit Emu. Or if you're at home, just know that you're okay to use the quadratic formula calculator online. Just know in class that you're going to have to type it in the TI-84. So it might be helpful to practice it. All right. Well, without further ado, let's just jump into the problems, factor some things, solve some things. We are going to solve, so we're going to find the values of x that make the equation true, right? So we're going to go the full way for each of these problems, but factoring first, okay? So here we go. Here's our first problem. We get x squared minus 11x plus 19 equals -5. Well, one little mental shortcut you can make is if you want to use any of these tactics, especially factoring in the quadratic formula, your equation has to be equal to 0, right? We factor so that we can find what the x would be if it was equal to 0. And so I need to first set up this equation so that the right side is just a 0 instead of a -5. Well, I can do that by canceling it in essence. Add 5 to both sides, right? Those will cancel out, and then I'm just going to be left with 19 plus 5. So my actual equation that I'm going to factor is this one. X squared minus 11x plus 19 plus 5 is 24 equals 0. Okay, so we need to factor this thing. And I like to use this little x, which is going to help me just organize my thoughts. It's not part of the problem or anything. It's just kind of a strategy to help me know where I'm going. You might do something like this where you set up A, B, and C, and then you find what A times C is what, and then B, if you add it together, right? It's the same sort of idea. I just like to have it in one place. And so in my x, I'm basically going to try and fill in these 2 squares, right? Or these 2 sides of my x. And I'm going to do so by finding numbers that correspond to this. At the top, I'm going to write A times C, which is your first term times your last term, or the x squared term times the constant. So that's going to be 24x squared. And then on the bottom, I'm going to write B, which is my middle value, or just the plain x, which in this case is -11x, okay? Well, I need to find 2 numbers that can go right here and right here, that when I multiply them, they multiply into 24x squared, but when I add them, add to -11x. Okay, they need to multiply to the top and add to the bottom. My way of remembering that is because you had to multiply A times C, which means they have to multiply to this anyway. Okay, so this is really the tricky part in the puzzle of factoring, right? Is figuring out what these 2 numbers are. What are the 2 things that multiply to positive 24 and add to -11? And so you might do something like this. You can set up a factor table. I'm going to think about the ways that I can multiply into 24. And obviously you have 24 times 1. You have 12 times 2. 3 can go into it 8 times. And then 4 times 6 as well. And I think then it flips over, right? So it doesn't really matter. And then what I kind of like to do is look at these and think about which one of these, if I were to add them or subtract them in some combination, could get me close to 11. And I see this too, right? 3 and 8. because I noticed that, well, 3 plus 8 is 11. If I take -3 and -8 and add them, I get -11. When I multiply them, a negative times a negative is a positive. So I basically just set up all my factors and found which one was close. And then I just had to think a little bit, because b was negative, these two are both going to be negative. And so I'm going to get -3x and -8x. Okay. Now, once we have these, I'm going to use the area model method. I think I'll actually show the grouping method in this video as well, if you're interested in that. It's kind of a less, I don't know, fancy way, but maybe it's more efficient if you're good at it. I don't know, but I always like the area model. And so by that, I mean, you can just kind of set up this type of thing. And basically, I can fill in the inside of these boxes, and I want to fill the edges with the terms in each of my factors, essentially. And so I just have to remember what to put in the boxes. Well, in the top left box, it's always going to be a, the first term from our original equation. Not this one up here, but instead just my x squared from my original equation. And in the bottom right, it's going to be my c term, 24. And then really what we did here with finding these is we split the -11x into two things. And so we're splitting the middle term, and we're going to write it in our boxes here. It does not matter where we put the 3x and the 8x in the box. It will change what we have up here, but it'll be the same answer either way. And now I just need to figure out what can go into these boxes such that if I multiply edge to edge, it gives me the thing on the inside. So it's kind of like a Punnett square, or like, I don't know, a Pokemon type chart or something. Okay, so first I need to figure out what times what would give me x squared. This one's not too bad. It's going to be x, not x squared. It's going to be just x and x, because x times x is x squared. And then x times what is -3x? Well, that's -3. And then x times what is -8x? Well, that's -8. And so I get these two things, my edges, and I can double check real quick too. I want to make sure that -8 and -3 multiply to +24, and they do. So that means I did it right. Okay, so I'm just going to I'm going to basically put parentheses around them, and then those are my sets of parentheses that this equation is equivalent to. So really now I just have to solve this. And if this was just a factoring problem, I'd be done, right? But I did want to figure out what values of x make this equal to 0. And really all that means is, I think on Mathia, it's called the zero sum property or something. Really, I just need to solve this equation. I need to solve x minus 3 equals 0 and x minus 8 equals 0. Because if either of my sets of parentheses is equal to 0, since they're being multiplied, 1, 0 will turn the whole thing into 0. And so really I can just see, well, x plus 3 equals 0. I can add 3 to both sides, and I get x equals 3. And then add 8 to both sides on this side, and I get x equals 8. Okay, so those are my two actual answers, x equals 3 and x equals 8. Those equate to this point, 3, 0 and 8, 0, right, as actual x-intercepts as well. So these two answers are what you're looking for. Those are the values of x that make this equation true. Okay, cool. Next problem. This one's a little trickier because this time we have a number in front of our first squared term. Our a term is not just 1. I hate that these are n. Maybe I should just change it to x. Should I just write it as x over it? There you go. Well, let me do a different color. It's kind of hard to read. I don't like n's as my variable. X is better. There we go. We'll just deal with x's. Well, first thing, kind of like the last problem, I see that it's not equal to 0, meaning, you know, it's equal 6 in this case. So I just need to subtract 6 from both sides first. Just one little trick that we're going to throw at you, which means that we have x squared minus 18x, and then negative 18 minus 6 is negative 24, and that equals 0. Okay, so we're going to basically factor this the same way. I like to set up my x, a times c on the top, b on the bottom. Well, a times c in this case is going to be my 6x squared times negative 24. I have a calculator for that. Let me see. I can just do it like this. 6 times negative 24 is negative 144. Oh, wait. I see an easier way to do this problem. Should I do it the hard way or the easy way? I'm not sure yet. I could do it either way. I'm gonna do it the hard way, just because if you see it too, I could factor out a 6, right? 6 can go into 6, 18, and 24. So I could factor out a 6 and make this an easy problem. I'm gonna try it the hard way just to see where we get. You know, feel me? So let's just do it like that. Because I feel like if I was on a test and I started this already, I might. No, I probably switch. But anyway, we got 144x at the top, negative 144x squared, and then my b term is negative 18x. Okay. So I kind of have to think about what are the ways that I can multiply to negative 144. And there's quite a few. I know that one of my numbers has to be negative, right? It's going to have to be a negative times a positive because I'm ending up with a negative number as a result of multiplication. So I'm going to start by thinking about ways to just find factors of 144. So I know that 144 can be divided by 2, 72 times. What about 3? 48 times. Both of these are not super helpful though, because I need to get a number negative 18, which is relatively small compared to my a times c. So I think I'm going to have to find the factors that are kind of close in size, if that makes sense. So what about well, I know 144 is 12 squared, but that's not going to help me. So I think it's going to be maybe less than that. What about 9? 9 and 16? Well, what is negative 16 plus 9? No, that doesn't quite work because we're trying to get to negative 18. What about 144 divided by 8? 18. Negative 18 and 8. No, that wouldn't work. What about 144 divided by 24? Ah, there it is. So it's going to be 144, 24 divided by 24 is 6. Well, I know that 24 minus 6 is 18, so we're close. Because my b value is negative, I want my larger of my two factors, my multiples, to be negative. So in other words, I found that the pair 24 times 6 works because negative 24 plus 6 is 18, negative 18, but negative 24 times 6 is negative 144. So my two factors are going to be negative 24x and 6x. Okay. So when I go to my area model this time, I know that on the top left, I'm going to have 6x squared, just always there. My bottom left is going to be negative 24, and then I can just put these terms however I like them, negative 24x and positive 6x. Okay. Now, I'm seeing something interesting with how we set up our boxes here. I mean, we have 6x squared and 6x and negative 24 and negative 24. I think that when that happens, it probably meant that I should have factored something out. I'm going to go with this, the idea that well, what are the ways I can multiply to 6x squared? I could do 6, I could do 6x times x, and that would give me 1 here and 24, negative 24 here. And I think that works, right? That works to me, right? Because negative 24 times 1 is negative 24. So in that case, my two parentheses, my sets of parentheses are going to be this. It's going to be 6x minus 24 times x plus 1. And that was equal to 0 because of this. And that means now I can just solve this set of equations. I just need to figure out when 6x minus 24 is equal to 0 and when x plus 1 is equal to 0. This one's easy enough. Subtract 1 both sides. I get x equals negative 1. And then for this one, though, I can add 24 to both sides. And I get 6x equals 24, and then divide both sides by 6, and that gives me x equals 24 divided by 6 is positive 4. So those are my two answers. -1 comma 0 and 4 comma 0. Cool. Oh, I realized that I was covering my, I was covering with the calculator the whole time. Oh, that's actually not too bad. I don't think that's too bad because it was only the right side that was tricky. Anyway, there's my math that I did. I got x equals -1 and x equals 4. Okay, which I think you would have got a lot faster if you just went ahead and factored out a 6, because yeah, it would have been easier. Anyway, here we go. There it is. Next problem. All right, this one I don't think I can miss on. I can't factor anything out, but I do have to add something to both sides, and that is the -15 right off the bat. And in that case, I get n. Actually, you know what? Let's make it an x again. Don't know why the math program we use doesn't have an option to allow us to find or just create equations with x in them instead of other variables. Okay, I don't think this one is. I think I can factor just this one as a plain old thing. So I'm gonna try it, and we'll see what happens. So I basically need to figure out a times c. In this case, is just 15x squared, and maybe I complete the square on this one. I guess I could. Is this one a tricky one? Because I'm trying to figure out right away what two things multiply to 15. Oh, never mind. For some reason I was thinking in my head 15 was prime. Yeah, it's not bad. A times c is 15x squared. B is 8x. What are the ways to multiply to 15? I was thinking 15 times 1, and I was like, there's no way it's divisible by 2 either. But 3x times 5x is in fact 15x squared. Add them up, I get 8x squared, which means if I want to set up this thing, my area model, I put my first term right in the top left, x squared, my bottom term, well, my c term in my bottom right, 15, and then I can put either of these two factors into these two boxes, call it 3x and 5x. X times x is going to be x times x. Well, that's x squared, sorry. And then x times what is 3x? Well, it's got to be plus 3. X times what is 5x? It's got to be plus 5. So then 3 times 5 is in fact 15, which means that I get x plus 3 times x plus 5 equal to 0, which means that x plus 3 equals 0 and x plus 5 equals 0 are the equations I want to solve. I'm going to subtract 3 from both sides, and I get x equals, I went blue for some reason, -3. And right here, I can subtract 5 from both sides as well, and I get x equals -5. So those are my points, -3, 0, and -5, 0. Cool. That one wasn't so bad. I should have put more problems with an a value larger than 1, because I think those are the ones that are tricky. So let's see if there's any tricky problems. Oh, okay, cool. I guess careful what you wish for. Well, actually, this problem is not too bad. There's just more than one thing on the right side of my equation. I can just set this equal to 0 by moving these things over, or in essence, like canceling them out, right? I want to do the opposite operation as it's happening to get it on the left side. Just as a result of having to do things to both sides. And so I see that I can add 3 to both sides here and add 5k squared to both sides, which is going to make this one easy again. Oh, come on. Or maybe not. Ooh, maybe not. Okay, wait. Hold on. Interesting. Let's see what happens. Okay. Let's see what happens. Okay, so I get 4k squared plus 5k. I know I was talking about not using k or only using x as a variable, but we can use k. No, I like x better. But I already wrote all the k's. Whatever, I'll just use k. This is going to be k squared, because -4 plus 5 is just left with 1, so 1k squared, or just k squared, minus 8k. And then this time, though, -3 plus 3 are also going to cancel. So I'm left with this, k squared minus 8k equals 0. Well, here's the trick. Here is the thing that makes this interesting, is that this is not really like a factor problem. It's more, once you're here, you can actually kind of solve it by noting that, or noticing that each of these terms has a variable in it, which means that you can actually factor out a k, right? Like I can take a k out of both of these because there's a k squared. Like this is basically k times k. This is -8 times k. There's something in common, the times k, which means I can actually pull it out of a parentheses and I'm left with just what I multiplied by. K times 8. That's equal to 0. And really what that means is, when can I turn either of these two things, either k equals 0 or k minus 8 equals 0? Well, k minus 0 is just one of my answers. And then I just have to notice that if I add 8 to both sides, I get k equals 8, which means that k equals 0 and k equals 8, or 0, 0, and 8, 0 are my x-intercepts, or my solutions. Cool. Cool. All right. I kept realizing that I had problems where the a value was just 1, which are helpful and you should be able to do them, but I feel like most people are struggling more with the complicated problems, or when a is not equal to 1 or bigger than 1, right? So in this case, like we have a 3r squared as opposed to a 3, or just r squared or something. And so here we go. I'm going to figure out this one, which hopefully should give me a little more trouble. I want to be tricked, you know? That's what I'm here for. Well, first things first, once again, it's not equal to 0, so I just have to subtract 5. Really, that's like kind of just, you know, a little check. Like, is that person paying attention when they're doing it? And so I end up with 3r squared minus 16r. I'm not switching to x again. Sorry. Should have maybe, but here we go. Here we are. Okay, and then this one's cool too because I can't pull anything out, right? I can't factor out a 3 because 3 does not go into 16. It does go into 12, but not 16. And so this problem, I just have to solve it as it is. And it is equal to 0 because I subtracted 5 from both sides. So here we go. Set up this. I'm going to put a times c on the top and b on the bottom. A times c in this case is going to be 3r squared times -12. That's -36 r squared, and then my b term is going to be -16 r. Okay. Well, in this case, I noticed that my a times c is negative, which means that the two numbers I'm going to find are going to be, one is going to be positive and one is going to be negative, just because that's the only way to multiply to a negative number. So I need to find both a positive and a negative when I'm figuring out what two things can solve this problem. And so I think what's going to be helpful is to just think about what are the ways to multiply to 36. So I can multiply 1 times 36. I can multiply 2 times 18. And I think I see it already. But you can also do 3 times 12, as we just did, and then 4 times 9, and 6 times 6. Out of all of these, the one that can possibly lead me to -16 would be this one, right? 2 and 18. And it happens if the 18 is negative. So I have a -18r and a positive 2r. And if I add those together, I get -16. If I multiply them together, I get -36. So boom, there we go. And I actually kind of want to do a method on this one without using the area model. But you know what? Let's use the area model again. The other method that you can use is called grouping, which is nice. And maybe I'll do another one after this where I'll group. So that's my idea. But for right now, we'll just keep using the area model. I recommend it because I think it's a little bit harder to make mistakes. So you can kind of figure out where you, like, maybe it's harder to figure out where you messed up, but at least you can figure out if you messed up if you're using this. whereas the other one is maybe some prone to more mistakes. So inside my boxes, I'm just gonna put my terms that I always put. So the A term, the first term in the top left box, and my C term in the bottom right. And then these two terms that I found from figuring out, what multiplies to -36 and adds to -16, I put in the other two boxes. And it doesn't really matter where you do it. Okay. And so when we go to solve this problem now, we have a little bit of a tricky situation, just slightly tricky, in the sense that we have to figure out what two things can multiply to 3r squared. Well, it's going to be definitely r times r, but it has to be something r times something r. And those two things have to multiply to 3. Well, the only thing that multiply to 3 is 3 times 1. So hypothetically, and if you're writing in pen, don't write this down because you're going to have to erase it. If I put the 3 right here, right? Let me make it red just to show that it's not a good idea. If I put the 3 right here, right? Once again, it didn't matter where I put the -18 and the 2r. It just matters what's on the edges. And so if I put the 3 right here, I notice that when I go to figure out what can I multiply to 3r to get to 2r, well, there's no whole number that does that. And if we're not going to use whole numbers, then why even try at all? So instead, I realized that I'm going to not put the 3r there. I'm going to put the 3r in a place where I can multiply it by something to get to the term within the box. So I'm going to put my regular r there. I know that r times 2, well, r times what is 2r? It's 2. R times 2 is 2r. And then 3 times something is -18. Well, that's 3r times -6 equals -18. And then just to double check, the +2 and the -6 multiply it to -12, which means that these are my sets of parentheses that I want. It's going to be 3r, I didn't mean to go blue, 3r, just 3r plus 2 times r minus 6. And that was equal to 0 because of this. And so I'm going to solve it. Really, that means I have to solve 3r plus 2 equals 0 and r minus 6 equals 0. Well, that just tells me I should add 6 to both sides. On the right side, I get r equals 6. And then I just have to two-step this one, which is subtract 2 first. I get 3r equals -2, and then divide by 3. And I get r equals -2/3, because those are going to cancel. So my 2 points that I want are 6, 0, and -2/3, 0. Cool. So this is a little bit more tricky. It happens if the value in front of your leading coefficient is greater than 1. In other words, it's not just x squared, it's like 2x squared or 3x squared or 5x squared or something. Okay. And really that's tricky about that. If you're used to using the area model, it doesn't get that much more complicated, luckily. So I recommend sticking with the area model even for the easier problems, because it can still help you out, at least having the knowledge to just apply it to harder problems. Okay, I'm going to find one that I'm going to use for grouping, and I think it's this one right here. So let me just go ahead and add it in. I'm going to do extra problems on this one. So we're going to go with this, and I'm going to use something on this one called grouping, factor by grouping, which if you see me do this and it just makes more sense, like it clicks better than the area model, then that's sweet. You're more than welcome to do this tactic. The area model and like anything I do in class is just to help us sort of organize our thoughts. And so if this is a better method for you, then use it, okay? So like all the other problems I've had so far, I just need to make sure it's equal to 0. I'm going to do that by subtracting 3. Oh, wait, no, is this going to be a nasty one? Oh, it's not even that hard. Never mind. You know what? We're not going to factor by grouping on this one. We need to find a new problem. We need to find a new problem, one that's going to not give us something that we can solve without thinking. How about, I see one, this one. This one's nice. This one's nice. This one's nice. Okay, new problem. Oops, it's tiny. There you go. Sorry, it's so pixelated. It is 35. Well, while it's all pixelated, let's just go ahead and subtract the 4 from both sides so we can write it nice. And then I'm going to replace the k's with x's too. So I'm going to go 35x squared minus 22x, not k, x, and then plus 3. Okay. Yeah, this is a nice one. This is a really nice one because I'm looking, is there something I can pull out or like factor out that goes into 35 and 22 and 3? Well, it would have to be 3 because 3 is as a prime number and it's included in this problem. So if I want to factor something out, it ought to go into 3 as well, and it doesn't because 3 can go not into 35 nor 22. So this is a good problem. Okay, so we're going to factor this one by grouping, which the first part is always the same, which is basically just figuring out what two things, like the puzzle, right? What two things multiply to what you want to multiply to and add to what you want to add to. And so the only difference is going to come after we solve this step. So for right now, we're going to do the exact same process. We're going to find A times C, and we're going to find B. Well, A times C is in this case 35 times 3, which is 105x squared, I think. 30 times 3 is 90, 15, or 5 times 3 is 15. So 90 plus 15 is 105. And then my bottom term is negative 22x. So I need to find two things that multiply to this and add to negative 22. Well, if my top thing, if A times C is positive, but B is negative, then I know that both of my answers have to be negative. It's the only way to add to this negative number is if my two things that I find are both negative as well. And so I don't have to worry about like multiplying a positive times a negative. So I can just find the factors of 105. And so I have 105 times 1. 2 doesn't go into it. 3, I don't know, does 3 go into it? Let's see. 3, where's my calculator? There it is. Turn it on. 105 divided by 3 is 35. Well, that doesn't work. What about 105 divided by 5? That's going to work. And it's 21. Okay, we're closer. How about 105 divided by 7? Oh, that's times 7. How about 105 divided by 7? 15. Ooh, that's the one. That's the one. I can do 7 times 15. That is equal to 105 when I multiply it. And then if I add them together, as long as they're both negative, if I add them, they're going to add to negative 22. So those are our answers. Negative 7x and negative 15x as well. And negative 7x. Okay. So, wait, 15x, not 7x. Thanks for catching me. Negative 15x. Okay. So here's where it gets different if we want to group. And really what that means is basically this whole process of figuring out these two values is figuring out what I can split the middle term or the b term into. And so really what this 7x and this negative 15x, well, negative 7 and negative 15, is this middle term split into two things. It's split into negative 7x and negative 15x. And so I'm going to rewrite my equation, but instead of writing the negative 22, I'm going to split it into the two values of x that I found. So everything else stays the same. I have 35x squared minus 7x minus 15x, and then drop down the plus 3. Okay? And now here's why you would do this. You now have two groups of numbers. You have this group right here. Okay? And you have this group right here. When you do this right, both of the things in your group are going to have something in common or something that you can factor out, right? And so for instance, when I look at 35 and 7x or negative 7x, I notice that the number 7 multiplies into both of these things, which means I can actually rewrite this equation as this. I can pull out the 7, And what I'm left with in parentheses would be 7 times what is 35x? Well, that's 7 times 5. So I'm left with 5. Oh, not just 7, but also, actually, I'll just continue like this. 5x squared, and then minus, well, 7 times what goes into 7x? Just minus x, okay? I'm actually, I went an extra step that I didn't need to because there's another common term, which is that each of these has an x in it. So I don't have to just also pull out just 7. I can pull out 7x, and on the inside, I'd be left with 5x minus x times what gives you negative x? Well, just x times negative 1 gives you negative x. Okay, so I've essentially factored out a term from my group on the left. I'm going to do the same thing from the group on the right. I'm going to throw just a plus sign in, and then I'm going to figure out what can I pull out or basically factor out from this group. Well, if you have a constant like this, it's often a hint. It's the number 3. And so if I pull out this number 3, what I'm going to be left with right here is, well, what can go into sorry, I was thinking of this negative is weird, this negative 15x. I'm actually going to do something a little bit funky, which is take out a negative 3 because I want my x term to be positive. Okay, so I'm going to pull out a negative 3. That way on the inside, I can see that, and just so that this is going to what's happened every time, 3 goes into 15 5 times, but negative 3 goes into negative 15 also 5 times. And this has an x on it, so I leave the x there. And then negative 3 goes into positive 3 negative 1 times. Okay, which means that in total, my equation is kind of this now. It's 7x times the quantity 5x minus 1 minus 3 times the quantity of 5x minus 1. Well, if you notice, I have two things in common in parentheses. I have 5x minus 1 here and 5x minus 1 here, which means that I can also sort of factor that out. I can say that 5x minus 1 in this equation is multiplying or being multiplied by the 7x from right here and the minus 3 from right here. Okay, so boom, that would be the factored version of this problem. And that is if you set up the area model, what you would get on the edges of your boxes. Okay, so it's the same idea. And basically what you're trying to do is set it up so that the things left in your parentheses in your groups are the same. So you're basically pulling out numbers until you have the same thing left in both of your parentheses. And then you just take the outside terms, like this one, and those become your second set of parentheses that you multiply by. Okay, this is called factoring by grouping. This might be nice for you. It might not be. If you want to stick to the area model, then be my guest. But if this way makes sense to you, it is a little more rewarding because it feels a little more tricky. It feels like you really did something with this one. You know what I mean? Well, if we want to actually solve it, which it was set to 0, and I've been solving all of them, so really we just need to figure out these. 5x minus 1 equals 0, and 7x minus 3 equals 0. You can just do that by two-stepping it. We got to add 1 to both sides on the left. We get 5x equals 1. And then we can divide by 5 on both sides. And we get, on the left-hand side, one of my solutions is x equals 1/5. And then on the right-hand side, I'm going to add 3 to both sides, get 7x equals positive 3. And then I'm going to divide by 7. And I get x equals 3/7 as my other. Which means that my 2 points that I'm looking for are 1/5, 0, and 3/7, 0. And that would be my answer, what I'm looking for. Oops, it just erased everything. 3/7, 0. There you go. Whew, that was a good one. All right, I feel satisfied with having a tricky problem. That one was tricky. That one was tricky for sure. But it's not too bad. It's not too bad. Honestly, yeah, I think I probably would have been faster with the area model. I can set it up right here. Because all you would do is figure out, well, this has to be 35x squared. This one is positive 7. No, positive 3. Gotta look at my equation after I subtracted 4 from both sides. And then it would be negative 7x and negative 15x. Well, what can go into 35? It would be 7 times 5, 7x times 5x. That's not the right way though, because if I look across, I need to get something times 7x here. And so I need my 5x on the top, my 7x on the edge. 7x times negative 1 gives me negative 7x. 5x times negative 3 gives me negative 15x, which means that my answers are 5x minus 1 times 7x minus 3, which is exactly what I got here. So there you go. I don't know. Whatever way works better for you. This one took longer because I had to explain it as well. But yeah, I like the area model. No judgment if you like grouping though. Okay. Whew. I need a break. I need to drink some water. All right. So this one. Let's try and factor it just right off the rip. If I say a times c and b on the bottom, that means I get negative 15 here and 14 here. That means I can just notice that it's positive 15x and negative 1x, because those multiply to negative 15 and add to 14. Let's try it an interesting way though. Let's try to complete the square on this problem, okay? Here we go. So what does complete the square mean? Well, complete the square means that you want to set up so that your left side of your equation looks like this: x and then plus or minus something and then quantity squared, right? In other words, you want to set up something times itself on the left-hand side, okay? Where that something is x plus a number or x minus a number. Well, when you multiply out, and let's say, for instance, like let's take x plus 3 quantity squared, okay? Well, this is the same thing as x plus 3 times x plus 3, and then you have to distribute this out, right? You have to multiply everything in one set of parentheses to everything in the other, which you know, you can use the area model for, or, you know, the acronym FOIL, but it's always going to end up with x squared, and then you're going to end up with 2 times the middle term. So it's going to be plus 3x, and then plus the last term, the constant, times itself, which is 9, which means you're always going to end up with basically x squared plus double whatever was on the inside before, x, and then squaring the constant term as a constant right here, okay? So basically what this can turn into is that if you see that your polynomial at the top has an even b value, then you could actually complete the square, okay? And so the square is going to be half of whatever your b value is. That's going to be on the inside of your parentheses, okay? So I'm going to erase all this for more space. That's kind of just a tangent to show what the thought process is behind it. And so really when I see this problem, I notice that 14x, well, that's 7, right? Half of that is 7. And so my goal is that I want the left side of my equation to look like this: x plus 7 quantity squared, okay? Well, in order to do that, I have to note, like that same thing from last time, that when I multiply this out, I'm going to get x squared plus 14x, and then also plus 7 times 7, which is 49. Okay. Well, this equation right here is pretty close to this one, except for the term, the c term, right? The constant term. In the one that I want, in my goal, it's 49, but in this equation right here, it is negative 15. And so all I'm going to do is some algebra so that on the left side, instead of negative 15, I have positive 49. So the first thing I'm going to do is add 15 to both sides. Okay, and then I get x squared plus 14x equals 15. And then I'm now just missing a constant term in total. I need it to be 49, which means I can add 49 to both sides. And I get x squared plus 14x plus 49 equals, what's 49 plus 15? I believe that is 64. Okay, there we go. Well, we wanted the left side of our equation to be this term, this polynomial, x squared plus 14x plus 49, because that's the same thing as x plus 7 quantity squared. Well, since these are the same thing, I can just rewrite and substitute x plus 7 quantity squared into this equation, okay? And what that allows me to do is now I can just solve for x using algebra, right? I can just do operations to both sides and eventually get what x is equal to. So I am going to first, because I have something in parentheses all squared, I'm going to take the square root of both sides. And I know that if everything in my square root is squared, then they're going to cancel out, right? This square and the square root, it's basically like raising this to the 1/2 power. When we raise exponents to exponents, they multiply, so it's going to be 1/2 times 2, which is 1. So really, I'm just left with x plus 7 on the left side equals, well, the square root of 64 is a nice number, but we always have to remember that it's going to be the positive and negative version, right? We're thinking what two things can multiply to 64? Well, that's plus or minus 8, right? Positive 8 times positive 8 is 64. Negative 8 times negative 8 is 64. And so we end up with this equation right here. X plus 7 equals plus or minus 18. And really what that means is I need to figure out what x is by itself. So I'm going to subtract 7, and I get x equals negative 7 plus or minus 8. Now, this is not really a good equation because this is actually two things at once. I can't combine these, as it were. I can't say that this is plus or minus 1, right? That would be negative 7 and 8. Instead, I have to think about this in the two cases, the case where I am actually adding 8 and the case where I'm subtracting 8. And so really what this gives me is the equation x equals negative 7 plus 8, right? Where for the plus or minus I added it, and then x equals negative 7 minus 8, which is when I subtracted from the plus or minus. Which then this one is going to be x equals 1, but this one, this is a 7, sorry, is going to be x equals negative 15. Which means that my points are 1, 0, and negative 15, 0. Okay, so that's completing the square. It's definitely, more of an abstract thing, and it's really a trick. Like, there isn't ever a problem where you have to complete the square. You can always use the quadratic formula. And so if you feel more comfortable using the quadratic formula, then by all means, use it. And in fact, let's practice it. And so let's figure out this problem. Actually, no, let's do this problem using the quadratic formula. I think the other one would be too easy. Okay. So for the quadratic formula problems, first of all, most importantly, you need to know what the quadratic formula is, which is, as the song goes, x equals, x being, the values that you're getting from the quadratic formula, x equals negative b plus or minus the square root of all of this, of b squared minus 4 times a times c. So it's x equals negative b plus or minus the square root of b squared minus 4ac, and then all over 2a. So including all of this left part, this b, the negative b plus or minus, that's all over 2a. Okay, now this plus or minus, once again, is going to mean that we're going to get two answers. We're going to get a version where we're adding what's called everything under the radical, right? And then we're going to also subtract it. So for this problem, I just need to figure out, I need to set it up so that it's in standard form, ax squared plus bx plus c. That's where we get these values a, b, and c from. And so this equation is close. However, the x is on the right-hand side. In order for it to be in standard form, everything needs to be on the left, and it should be equal to 0. And so I'm going to subtract x from both sides. I don't know why I wrote the number 8, x, which is going to leave me with 2x squared, and then I subtracted x, so I wrote 8 again, minus x, and then minus 36. And that equals 0. Which means that a is 2, b is negative 1 because it's negative 1x, and c is negative 36. Okay, so when I go to set up my formula, here's what it's going to be. It's going to be x equals, it's going to be negative 1. And I like to just like not do anything first. I want to just write all the negatives out, leave it nasty, and then just simplify it as I go and try to do as many simplifications in one step. And so that's going to be negative 1 squared from the b squared minus 4 times, what is a? A is 2 times c is negative 36. Oops. And then the square root is all over that. I just want to make sure that happens. And then this is all divided by 2 times 2, because a is 2. Okay. Well, really what this is now is I can now simplify it a little bit nicer. I get x equals negative 1 is just positive 1, plus or minus the square root. Negative 1 squared is just 1. And then I have to think about what is negative 4 times positive 2 times negative 36, right? In other words, negative 4 times 2 times negative 36, that is plus 288. So I kind of included the negative in the, or the subtract 4ac, I included that in the negative 4, right? If you wrote it as 4ac in the calculator, so you did 4 times 2 times negative 36, then you just have to know you're subtracting negative 288. That's the same as adding 288, right? Well, I can also just say, well, now this is all over 2a, which is 4, which means that in total now, my equation is this. X equals 1 plus or minus the square root of 289, that's 1 plus 288 over 4. And what you have to do is then figure out, kind of like the last problem, the version where you're adding and the version where you're subtracting, right? The version where I'm going to add square root of 289 and the version where I'm going to subtract square root of 289. And so I get 1 plus square root of 289 over 4. That's what x is going to be. And x is going to be at 1 minus 289, square root of 289 over 4. Well, if I want to just plug it in the calculator, I can just do it like that, right? And so my trick for plugging into the calculator with this fraction is that if you hit alpha, which is the green button, and then y equals, and then enter, it's going to be this n over d, hit enter. It's going to pop up a little fraction for you. Here, let me see if that can do that. Can I detach the CD? No, it doesn't show. Anyway, so it looks like a fraction on my screen. It's kind of tiny. But basically, I can now just type in 1 plus square root of 289 over 4 and hit enter. And that way I don't have to worry about accidentally dividing, and I also don't have to worry or dividing the wrong thing, or, you know, accidentally not putting the parentheses in the right place. I get 9 over 2. I think 289 is a nice number. Square root of 289 is a nice number. But anyway, and then if you want to just do the negative version, you can just scroll up to it, hit enter, and then scroll over until you are at the plus sign and just change it to a minus, and you get negative 4. And so those are my two answers, 9/2 and negative 4, which means that the two values that I'm looking for are x equals 9/2 and x oops, and x equals -4, which in turn is 9/2, comma 0, and -4, comma 0 as coordinate points. Okay. Woo, there we go. That's it. So some review on everything. I highly recommend getting quick with factoring. And then also just with these quadratic problems, quadratic formula problems, just making sure you are keeping track of the plus and minus signs. You really don't want to mess up from the beginning and then start getting errors because the thing in your square root is negative. And then we just talked about imaginary numbers. So you might think it's an imaginary answer when it's not. Just please be careful, double check all of your minus signs, simplify it to the point where you feel comfortable typing into the calculator without any mistakes, and then just go from there. Okay, cool. All right, best of luck. Good luck studying for the other topics on this, such as graphing quadratics. And yeah, thanks for watching.